About the construction of a galvanic cell. Today we are going to discussing about the representation of galvanic cell. So this is an galvanic cell. So I am again I am represented the construction of the galvanic cell here. I am shown the construction of galvanic cell. This is the galvanic cell. Okay, this is left hand half cell. This is left hand half cell. This one is the left hand half cell. This one is the right hand half cell. These two half cells are connected with an salt bridge. This left hand half cell, also known as anodic half cell. In this anodic half cell, oxidation takes place, hence also known as oxidation half cell. Right hand half cell, also known as cathodic half cell. Here reduction takes place. This oxidation, so which element is undergoing oxidation? This zinc rod undergoing oxidation and converted into, zinc is converted into Zn2 plus. Here I am shown that one. So zinc is converted into Zn2 plus. That same thing I am represented here, Zn slash Zn2 plus here. Zn slash Zn2 plus means Zn is converted into Zn2 plus by losing the electrons. The same thing with Zn2 plus means it is entering into the zinc sulfate solution. So after that Zn enters into zinc sulfate solution, it also becomes ZnSO4. So this is ZnSO4. Like this also we can represent, like this also we can represent. Similarly, the reduction half cell. This is the reduction half cell. Look at here, this is the reduction half cell. This reduction, this right hand side half cell, this right hand side half cell or reduction half cell, also known as cathodic half cell. In cathodic half cell, reduction takes place. Which element undergoing reduction? Cu2 plus is converted into copper and deposited on cathode. Here this copper is deposited from this solution. In solution, the copper is present as Cu2 plus. All these Cu2 plus are going to deposit at the cathode by undergoing reduction. So Cu2 plus convert into Cu. The same thing I am represented here. I am shown the same thing here. Cu2 plus converted to Cu. If other than copper is present, those things are written like this: metal 2 plus slash metal Mn plus slash M. Here the Cu2 plus is in the form of copper sulfate. So this one also can be represented like this: CuSO4 slash Cu. So so look at here. Here Zn2 plus is converting into Zn2 plus. Here a slash is there, Zn slash Zn2 plus and Cu slash Cu2 plus slash Cu, like that slashes are there or vertical lines are there. What is this vertical line? This vertical line represents the intersection lines between the electrode and electrolytic solution. It is the plane where electrode and electrolytic solutions meet. So the plane where electrode and electrolytic solutions, electrode and electrolytic solutions meeting are represented with a slash or a vertical line. And this, in a galvanic cell we have two half cells. In a galvanic cell, two half cells are connected. Here we shown only one half cell representation, here another half cell representation is shown. But in a galvanic cell, two half cells are connected with a salt bridge. To represent the salt bridge, two parallel vertical lines are placed. So these two are the parallel vertical lines. These two lines represents the salt bridge. Now a complete galvanic cell is represented like this. To the left of the salt bridge, this is the salt bridge. To the left of the salt bridge, oxidation electrodes are written, oxidation of reactions are written, Zn/ZnSO4, that means this one. To the right of the salt bridge, reduction half part is written. This is the reduction half part, CuSO4/Cu. This is the part. These two are connected by a salt bridge, two vertical lines. Okay. Next, simply this one can be explained like this: Zn/Zn2 plus salt bridge Cu2 plus/Cu. Our next topic is overall cell reaction. That means you have to write down the complete galvanic cell reaction. Here I am considering one of the galvanic cell constructed with zinc and copper. So zinc copper couple galvanic cell reaction. For this cell I am writing the overall cell reaction. For this, first you have to do is write down the oxidation half reaction. In zinc copper couple galvanic cell reaction, which element undergoes oxidation? Zinc. So write down the oxidation of zinc. I am written the oxidation of zinc like this. Zinc gives rise to Zn2 plus 2E minus. This process is taking place at the anode. So this is anodic oxidation reaction. Next, at which part reduction takes place? At cathodic half reaction cell, reduction takes place. This copper undergoes the reduction. So I am written the copper as reduction. Cu2 plus gains 2 electrons and converted to Cu. This reaction is taking place at right hand side electrode, that means cathodic half reaction. If you add these two reactions, you will get the overall cell reaction. This is the overall cell reaction of zinc copper couple. This is the overall cell reaction. Okay. Zn plus Cu2 plus Zn plus Cu2 plus gives rise to Zn2 plus Cu. Like this, if you write the overall cell reaction, you can write the overall cell reaction. Now I am considering another galvanic cell. I am considering another galvanic cell, and that galvanic cell is this one, Cu/Cu2 plus /Ag plus/Ag. We already know that the species which are present at the left side of salt bridge, this is the salt bridge, the species which are present at the left side are undergoing oxidation. So you have to write down this copper as oxidation process. So Cu gives rise to Cu2 plus 2 electrons. This is oxidation process of copper, which is taking place at the left hand side of the galvanic cell. Now look at the right hand side of the galvanic cell. Here Ag plus Ag is there. That means Ag plus is converting into Ag. That means at the right side of this salt bridge, you can see the reduction process. Here the reduction process, Ag plus takes one electron and converted into Ag. Ag plus takes one electron and converted into Ag. To balance the number of electrons in oxidation reaction and reduction reaction, you have to multiply the Ag plus equation with 2. So 2 Ag plus 2 electrons gives rise to 2 Ag. So here 2 electrons, here 2 electrons. Now write down, add this both the reaction, both half cell reactions, anodic half cell reaction and cathodic half cell reaction. Add these two reactions. So Cu plus 2 Ag plus gives rise to Cu2 plus 2 Ag. This is the overall cell reaction of this galvanic cell. Next, look at another galvanic cell, and that one is PtH2 slash H plus comma Cl minus slash Cl2. For hydrogen, platinum is the electrode. For chlorine, here they taken as graphite rod as the electrode. Now look at here. This is the left hand side part. This is the right hand side part. Left hand side part undergoes oxidation. So you have to write down this part as oxidation part. So I am shown here the oxidation part of left hand side, and H2 gives rise to H plus E minus. So hydrogen undergoing oxidation. Oxidation means loss of electron. So here one electron is lost. To balance this equation, I am using this half. So half H2 means this 2, the half 2, and this 2 get cancelled. So how many hydrogens are there here? Only one hydrogen. This one hydrogen loses one electron and converted to H plus. Now look at the second one. This is the right hand side part, this part. So this part undergoes reduction. So I am shown this reduction here. Chlorine gas takes an electron and converted to Cl minus. Here also the same thing. So to balance that one, I am used the half. So this half, these two get cancelled. So Cl plus E minus gives rise to Cl minus. Now add these both reactions. So half H2 plus half Cl2 gives rise to HCl. This electron get cancelled. Okay, like this you can write down the overall reaction of a given reaction. You can write down the overall reaction of the given galvanic cell reactions. These are the galvanic cells. If they given the galvanic cell, you have to write down the overall reaction like this. Okay students.